Good morning all, and hi to everyone online as well. So we're here at COP, and we know that a huge part of the reason we're here is that our governments are committed to reduce carbon emissions. But I think sometimes what can be lost is that, of course, there are two other parts of the UN Framework Convention on Climate Change, and that's focused on adaptation and loss and damage. What we're here to talk about today is how action and how, in particular, how data can be used to support our communities to build their resilience to what we already know is dangerous locked-in climate change, and also how data and digital techniques can be used to build the resilience of our infrastructure. And our infrastructure, of course, underpins everything we do. It underpins the safety and security of our communities, it underpins the economic activity of our societies, and we know that increasing the resilience of infrastructure, increasing the sustainability of infrastructure systems is absolutely critical to the future of our societies. In terms of resilient infrastructure, and this is something that's close to my heart, it's an area that I've been practicing in for over 20 years now. I like to think of resilient infrastructure in two ways. Firstly, of course, the usual way we think about resilience. The infrastructure itself needs to be resilient. It needs to be resilient to extreme weather events and to future climate change. We don't want roads getting destroyed by floods, sort of obviously. We want them to be able to be recovered quickly after the inevitable extreme weather events. We should also, though, think of the impact that infrastructure can have on conferring resilience to its surrounding communities as well. We tend to think of infrastructure, and having been involved in delivering tens of billions of dollars of infrastructure around the world, as a point-to-point solution. So a road goes from point A to B. We might think about the community a little bit in terms of construction impacts, but we don't tend to think about how that infrastructure can confer resilience on its users and its surrounding communities beyond the sort of narrow conception of infrastructure itself. And so the way that we deliver infrastructure, the way that we consider the benefits of the infrastructure, the dividend, if you like, that infrastructure provides to its users and to its surrounding communities is incredibly important. And data, the use of data and digital techniques is at the centre of this because, of course, it's incredibly complex. So we've got a fantastic panel here joining us today. We'll have a Q&A with the panel that I'll lead for sort of half an hour, 40 minutes, and then we'll make sure that we have some questions, some time for questions from you, so please jump in. So immediately to my left is John Mennel. So John is a colleague of mine from Deloitte US, and he leads sustainability for our strategy practice. To John's left is Ahmed, and Ahmed is from Esri, and he's a principal consultant at Esri. To Ahmed's left is Farrukh, and Farrukh is head of sustainability for Schneider Electric in AP and the MENA region, so just a small part of the world. And to his left is Timurhan, and Timurhan is from Arup. I was at AECOM for many years, so I'm in my happy place on a panel with a senior engineer. Timurhan is a member of Arup's board of directors in the region. He's a senior structural engineer, and he works a lot in digital systems. And so, Timurhan, I'd like to start with you, if that's okay, and your thoughts on this question of how we can use data more effectively to deliver more resilient infrastructure.
Thanks, Will. I would like to start with our engineering process, how we deal with the structures, more focusing on the existing structures, because from my experience in the past, to change the communities to more resilient environment or place, the most challenge is on the existing structures or infrastructure. And from my experience, dealing with those huge amount of structures, let's say, you need very, practical, efficient ways, methods to deal with. Because the problem is huge, and with the current, capacity of engineers, you need years and years to overcome the issues on the existing infrastructure. So in our engineering processes, we tend to use simplistic processes or procedures, which result in more conservative outcomes. And that is not sustainable really, so high cost. But then we tend to use, especially in the recent years, more advanced engineering technologies or methods, which requires more time, more effort. So the issue is how we can scale up the advanced technologies, advanced engineering methods in the existing infrastructure with the use of technology. And of course, the first part of it is how we can get the data from existing structures. So with the existing structures, most of them lack documentation, especially as-built documentation. So you need to collect the data in a very proper way, very reliable way, so that the advanced engineering methods that you are using, which depend mostly on the reliable data, will be more meaningful. Otherwise, you may lose really the consent and etc. So we really focus on how we can get that data properly. So there are, and also how to use that data in different environments that we use the engineering and etc. So my perspective would be, as I mean, response to your first question, maybe I don't need to make it a long speech at first, but so focusing on how to get the data from existing structures in a proper way and how to structure that. Maybe we can talk on that later. Yeah.
Excellent, thank you. So access to data and enabling the sharing of data through data platforms. So Farrukh, I'd love your thoughts on those topics.
Sure. Hi, everyone. Thanks for having me on the panel. I represent APMEA region, which is Asia Pacific, India, Middle East, Africa. Now, if you Google the hottest countries in the world, you will find the top 10, which might be in my zone, which are in my zone. And if you Google the effects of climate change, and you will see all those countries in the zone as well. Now, the interesting part is, if you look at the infrastructure that is needed to mitigate some of those effects, that's really not in place, or it is coming into place, but I'm talking about brownfield and greenfield both. From that aspect, what is being done on the data side? Are we sharing data? Do we have radical collaboration between governments and private companies to share data on what would be the effect of climate change, how to build resilient infrastructure? And there are a lot more questions than answers on that topic. Hence, there is an urgent need. There we have open data platforms, we have data hubs, which are being used, and there's a collaboration that is going on. I'll give you some stats from the US itself. I was looking at some stats which said US can unlock 3 to 4 trillion US dollars in economic value if data is shared by government with private companies. And I'm talking about housing, I'm talking about transport, I'm talking about oil and gas. So there is a lot of need for data sharing and data hubs being created between public and private sector.
I'd love your thoughts on some great sort of best practice examples of using Esri's platform and data services to help keep people safe. Because we know, of course, that we need to adapt our infrastructure to climate change to keep the infrastructure safe. But as recent events in Spain have shown us, events in my home country in Australia and all over the world, extreme weather events are becoming more frequent, they're becoming more damaging, and even worse, they're changing in their distribution. And so how is Esri supporting communities using its unique platforms to stay safe?
Well, thank you for that question. I just want to continue from what my colleagues started about the data and the shareability of the items, because it's a big deal. People talk about resilience, people talk about risk and assessment, but one of the major challenges is actually fusing that data. And that's in the heart and the core of our geospatial technology. In fact, this is one of the items that we insist and make sure it's well organized through the different open data standards, making sure that the data can stream between the different organizations in a seamless way so they can actually collaborate and get answers. I mean, one of the major challenges is you have a lot of data sources, but they are dispersed. You have no use of them, different standards. So when you try to combine them together, you're not actually getting the useful input that you're looking from there. You're actually cleaning the data or trying to repurpose the data so you can make use of that, which is a very painful point to that. I'd like to refer actually in the design phase, one of the key aspects that we think is very important and crucial, something that we call geo-design, is actually from the early stages of doing the infrastructure and building, taking into consideration the aspects of what's surrounding you. So it's an innovative framework where you take into consideration the design, also the geography, which is the surroundings, and the technology as well. When you combine these all together, you actually can start on a clean slate, as they say. Our president likes to call that designing with nature, because now you're actually ready to fight whatever kind of risks that is going to come your way when you're doing that. If you move after that, talking about the sensors, talking about the other data feeds that you're getting, actually the world of geospatial technologies have evolved a lot over the years. So we're not only talking, when people hear sensors, they would think IoT sensors, building sensors, SCADA monitoring systems, but it's actually wider than that. Now the satellites is some sort of sensor that actually gives us eye from the sky on what we cannot see. Now the technologies have evolved so much where we actually have sensors that can penetrate the Earth and, for example, detect if there is a potential leak without the need to dig and disrupt the infrastructure. All these kind of possibilities are being achieved with an innovation of the technology and leveraging the different pieces as well. So that definitely helps a lot.
And Ahmed, a follow-up, if that's okay. You told me before when we were chatting for the panel about a great example from the US around emergency management. Would you mind riffing on that?
Of course. So, for example, on that specific point, FEMA, which is the Federal Emergency Management Entity, uses our technology, fusing all the different layers so they can assess 18 different risks like tornadoes, like floods, like any other kind of disaster. And then they calculate what they call the National Risk Index, which is actually very important for any land development, for any real estate development, understanding the area that we're trying to build or develop, what's going to be the risk index for that. Also taking into consideration the vulnerable communities around that. So emergency management can prioritize the services when they're responding to an extreme event like a fire happening and so on. Yeah.
Wonderful, thank you.
Thank you.
John, I'd like to come to you and your thoughts around the types of data and from your experience in working with clients, how can we make that more accessible and more actionable?
Yeah, and I'd like to pick up on a couple of the very good points that my colleagues have made. One is the importance of fusing data. That has come up a couple of times, to be able to use data from multiple different sources, whether it's private sector data from the property owners, public sector data that exists from the emergency services and from government, Earth observation data from satellites, sensor data, all of that needs to be fused to get to a comprehensive answer. And we're working with Esri and some of our other technology partners to fuse that within usually a GIS system that's able to look at what are all of the different hazards and how are they able to affect the properties that we're looking at. And some very specific cases that if there's a major storm on the coast, what is the effect of that storm surge up a river system? And properties that are very far inland, what's the flooding risk from those? And you need to be able to fuse data from many sources and feed it into a GIS system or other system to be able to predict those kinds of hazards. At the end of the day, though, what we're trying to help our clients do, whether those clients are a large property owner like a manufacturer, an insurance company, a government, a retailer, a large hospital, is to think about two things. What is the probability of risk from each of the hazards? And one of the major adjustments to make is that estimates of probability have been generally backward-looking, right? And there's an assumption that we have a 100-year storm or a 50-year storm that we need to plan for when we engineer and when we design a building. And as we all know, those 100-year storms are not 100-year storms anymore, right? They're often 10-year storms. And so the way that we think about the design and think about the refurbishment of properties needs to reflect those differing probabilities. And then the other is the impact. And so what is the impact on that specific property? Whether it's a hazard from fire or storm or extreme heat, what is going to be the effect on each kind of property? And with our clients, we generally, using a GIS system, we model that out on a property-by-property basis. We also look at the effects beyond the property, so what's likely to happen to the road networks, what's going to be the effect of health on people, the ability to travel in those kinds of situations, and try to give clients a rounded view of the risk. And then the next thing that I'll probably save for another answer, it's important, is once our clients understand what the risk is to the real property, what do you actually do about that, right? And then that's in some cases the more important answer, and I'm sure we'll get to that.
And this is a great point to bring Timurhan you into, because you lead engineers, and you've as a senior structural engineer, you've worked on many projects that use these design parameters to ensure that buildings are successful in whatever it is that they need to be doing. Certainly that they stay upright, and that they protect inhabitants and they enable inhabitants to thrive within them. I would love your thoughts on how your teams are adjusting to these changing parameters as a result of the changing climate, when there's a great deal of uncertainty. When your engineers, they need the number to design to, and it's quite hard to get that number with a high degree of certainty now, and how you're using digital capabilities to help answer those questions.
Thanks, Will, again. Just before going into this question, now I listened to other colleagues explaining about how data is being gathered and used. And I feel that generally it is a great thing to get those data, like satellite data but these are like high-level data for a structural engineer, because we need to dive into the buildings or bridges, which are generally unique structures. So a concrete building is not the same as the other concrete buildings in the same region or from the same year. So we need to work building by building, bridge by bridge, all infrastructure components, and that is our challenge, in fact, getting the data from each and every structure. So coming to your question, how we use this new data. So for the climate change, we are using some prediction tools for the future. So in the past, like say 10 years ago, we were referring to some climate parameters from the say meteorological institutions, which gives us the past 50-year data. And we were designing our structures or our say drainage systems, infrastructures, based on this past 50-year data. But we know that now it doesn't work. So we need to look to the future. And in Arup, we have developed some tools which can predict, say, next 50 years, next 100 years data. And in all of our projects now, we are using those, we are generating those data and use them in design. So that brings some, say, safety or additional safety to the systems that we design.
And as a follow-up to that, how do you deal with the marginal cost associated with the increase in resilience? So that data might be suggesting that you need to use a 200 millimeter pipe instead of a 100 millimeter pipe, and that comes with additional cost. Your client has always used 100 millimeter cost. How do you have that conversation with them when the reality is we don't know what the climate's going to be in 50 years' time? We can forecast, but no one knows.
Exactly. So that is a very critical question. Thank you, because it is a challenge for us also to explain this to the clients. So it is not only for the climate change, similar as earthquakes. So we need a performance specified and accepted by the clients. So the codes, the standards, gives the minimum performance levels. But in fact, they also accept a limited amount of damage in the system. If I give you an example, say industrial buildings, I'm dealing with them very intensely during the last 10 years and dealing with their resilience, including seismic, flood, etc. And the codes generally treat the industrial buildings as normal importance buildings. So they allow or they accept a level of damage in those buildings, which will end up like interruption to the business after a disaster. But when you talk to the clients, the owners of those industrial facilities, they generally are not aware of this issue. They always think that if a building or facility, a structure is designed to the standards, it's okay even after disasters. But it's not the case. So explaining to them, telling them the value of having 200 millimeter pipe or instead of 100 millimeter pipe is really difficult. We succeed time to time, we fail to succeed time to time. So we fail time to time, but it is very important. We need to explain that it's responsibility of all of engineering community.
And to add further complexity, of course, the industrial facility doesn't exist by itself. It relies on a supply chain, it relies on workers.
2 years ago there was a devastating earthquake in Turkey, southeast of Turkey, and that triggered lots of discussions and actions as well. So one of our clients, with our guidance, they started a program for their suppliers. So we are now assessing all of their suppliers, like more than 100 factories in Marmara region. So that triggered other associations of, say, supplying companies. So now more than 500 different factories are started to be being assessed in terms of different, say, resilience parameters or activities. Yeah.
Fantastic. And it goes to that point that I made earlier about the resilience of the infrastructure, but also the resilience conferred by seeing it as an ecosystem. I'd like to turn to simulation and digital twins in particular. Deloitte in my home state in Victoria in South Australia has built a digital twin of the entire transport network. And this was done to effectively sweat the assets, to try and reduce capex on new roads by building more efficiency through the live optimization of the transport network. But what we've found actually is that we've started augmenting that digital twin to enable the transport network to cope better with extreme weather events, to enable egress of communities from disaster zones and ingress of emergency services. There's a huge issue with disasters that you have people trying to evacuate at the same time as first responders trying to get in. And so Farrukh, I'd love your thoughts and if you have some good examples of the use of simulation in particular to sort of optimize the existing infrastructure or to optimize the design of new infrastructure.
Sure. Starting with digital twin, which is basically a virtual replica of a physical infrastructure. What we in Schneider do is we have an open IoT-based platform which kind of runs all the industrial unit or a residential building or a commercial building. And we are able to simulate, we do real-time monitoring on what are the consumption patterns. We do analysis, we do scenario planning, we can do climate adaptation as well. In places like Hong Kong, for example, if there's a typhoon, then what would be the reaction of the building and how do we need to simulate that? We are able to do that as well. We do similar for factories in industrial units to have a digital twin and do some simulations and scenarios. So yes, for that, we need to have an open IoT-based platform. We need to have a digital infrastructure ready for that.
And have you seen any really good examples of this being used in cities or with infrastructure systems?
I see it is being used in Singapore, for example. Singapore government shares data They have digital twins for critical infrastructure, and they share data as well. I see that in advanced economies there. I see it in Hong Kong as well. So yes, there is some good examples, but then at the end of the day, it comes about how much investment is needed, what is the return on investment, and how the collaboration is happening.
Fascinating, thank you. And Ahmed, I'd love your thoughts on this, on the use of geospatial tech, machine learning, and how AI is being integrated to help transform these systems.
Sure. I mean, we all hear about the deep learning and AI and machine learning. And in geospatial, we deal a lot with data from various sources, satellites and even regular tabular data, as long as it has location information with it. And combining those together enables you to be able to predict, identify some of the pieces that you'd be looking for. To give you some of the examples, we've worked with NOAA, for example, in the US to develop the national water model, which is actually gathering from a huge network of sensors on all the rivers and the streams, and also integrating with the weather services as well, to be able to predict how the water flow will happen for the next few hours, for the next 10 days. So when you combine that with the digital twin and you have the location aspect as well, you can actually take that into consideration. So you can actually prepare a mitigation plan and so on. On the simulation part specifically, one part of our technology actually enables you to run those simulation scenarios. So if we got hit by a flash flood or a heavy rainfall, for example, how the water is going to accumulate, because we have the data, right? We have the elevation, we have the digital elevation model and digital surface model, and we can run these simulation scenarios and overlay and intersect those with all the layers that we're interested in, the buildings, the facilities, the infrastructure, and based on that, we can actually proactively prepare mitigation plans, and then run the what-if scenarios. What if we put the sandbags here? How the water actually is going to divert. So this is something that is real, something that you can do in few hours, if you have the data, of course, and it helps you be better prepared for the things that we see nowadays. I mean, what we saw in Spain was a huge disaster. This year in Dubai, for the first time in over 60 years, we've seen an unprecedented waterfall that flooded the city, even though that the city is modern and new and they have amazing discharge water systems, but they couldn't stand it. But giving them that ability, when they integrate that with the weather information and real-time information, they should be able to proactively prioritize and put plans to mitigate those things. Yeah.
I was in Abu Dhabi when that rainfall event hit, and it was remarkable. It was some of the most powerful rain I've ever experienced. Yeah. Exactly. And so we have these new tools. We have these very powerful and exciting insights being driven by the ability of organizations like Esri and others to coalesce and fuse this data into remarkable insights. John, with our client work in the US, we often form the bridge between the data systems and client need. What do you see as the barriers to adoption? Because it's certainly not optimal at the moment.
Well, I think we're starting to see a lot more adoption. Just to add to some of the examples given, we've done digital twins in Broward County, Florida, with the California transportation system that are doing a lot of the exact same scenarios that my colleagues are talking about. It's helping move from planning. So what do you do? How do you plan for the systems? And then we're also using this for scenario modeling and wargaming, right? So to run through what a severe scenario would look like, and the severe scenarios are becoming more and more common, and planning what the relief services would do in that case. And so that's becoming more and more common. I think one of the things that has impeded adoption is that for a lot of property owners, there is a reluctance to admit how much value is at risk. And so I have an insurance client who believes that the property portfolios of a lot of the major U.S. real estate investment trusts maybe 40 to 60% overstated in their value based on the risk to those properties. And so a lot of the work that we're doing with our clients is helping them put some financial parameters around the decisions that they're making for new builds and for existing builds, whether it should be that 200 millimeter pipe, to help put some scenarios around should we do that now or should we do that later, and hopefully make some of those conversations easier for the engineers. And we use a model that is actually something that was developed by Professor John McCumber at Harvard that talks about the 5 R's. And the 5 R's are the decisions that you could make when you're planning a property or when you have an existing property. And that's everything from rebuild, to say that we're going to assume that we're not going to build in existing new resilience measures. We're just going to rebuild this structure if there is a devastating event. And that's one scenario that people take, and you can model out how that looks. And that goes all the way through other scenarios, from reinforce, which is we have an existing building, we evaluate the hazards, we invest the CapEx now to invest damage down the road, to rebound, that we have a plan that if there is a hazard for the structure, that we're going to build it in a different way next time, and we're going to keep the reserves so that we're able to do that. To restrict, which is we're going to restrict what we're going to do in this specific hazard area with the building, and that may be for a public sector provider, or it could be for a company, that we may just not have factories in this area that's particularly hazard prone anymore. All the way to retreat, which is we're going to retreat from this area completely. And for a property owner, that may be we sell while we think that there's some advantage to sell now in the market. To a public sector owner, maybe that we change the zoning so that we're not building in this floodplain or we're not building in this fire-prone area. And when we have the data that we've talked about, the ability to run scenarios, input from our engineering colleagues, all the sensor data, a lot of times where the rubber hits the road is to really cash flow out those 5 scenarios and help clients make decisions about what they should be doing at this point.
Thanks, John. So in addition to reduce, reuse, recycle, we have restrict, rebuild, rebound, right, etc. Too many R's.
New 5 R's. Yeah.
And of course, a big part of this decision, I think, Timurhan, as you were alluding to earlier, is the design life of the asset and its criticality. And so having a conversation with a client about if you have an electricity terminal station, your tolerance for that to flood is very low. But if you have an industrial facility where you can site critical infrastructure above the ground, perhaps your tolerance is a little bit higher and the design life might be a little bit lower. So, Timurhan, I'd like to pivot now to sort of the human dimension and the role of collaboration in this. And something that I really enjoyed in my time in engineering firms is that because these infrastructure projects are so big, you're always collaborating with who are your sort of erstwhile competitors, but also the best way to deliver infrastructure is in collaboration with the person that's funding it and the person that's going to use it. So I'd love your thoughts on the role of collaboration and how important and what mechanisms Arup uses to drive collaboration in its infrastructure delivery processes.
I think that is vital, essential, to have that smooth collaboration or proper collaboration between all the stakeholders. So there again, this data is coming in, and what we try to do is to define a common data environment in the start of all projects. So we try to define how the data will be collected, stored, used via different software packages, tools, etc., and how it can be exchanged between different software tools so that it can be used by all stakeholders, as you said, the investor, the user later on. So that is also like the base of the digital twin. So if you start from the beginning in a proper way, then building your digital twin is much easier. And then the user can also benefit from it during the lifetime of that structure. So common data environment, how we can define it. As Arup, we try to define a global standard internally for ourselves, how we use, say, the BIM models, how we are going to define different components of a BIM model. So we have our own standard, but I think it has to be like really a global standard worldwide, and which will be used by different parties. So each stakeholder, from their perspective, they need to have a, say, common definition of their part, so that the transition between different parts will be like really smooth, easy. One more addition to the previous one, the 200 millimeter, 100 millimeter diameter issue. So from our studies, we also do some cost estimation as well. So in an infrastructure project, if you are building an industrial facility, let's say, the investment done on the structural or infrastructure members, the parts, is generally like 20%, say maximum 30% of the whole budget of the project, because the most valuable thing is generally the content, the process in an industrial facility. So having a bit more investment there will affect, say, 3 to 5% of your initial investment. But the benefits you get is much higher. So say in a flood, if your process equipment are damaged, then the cost of it is really very high. So that's another review.
Yeah, and just to respond, that's exactly my point, is that they're basically, when you understand what the range of probabilities of the hazards can be, there can be three choices. You either have additional expense up front to make the building more resilient, you reserve to be able to repair down the road, or you decide that you're not going to repair, you're not going to build in the resilience, and you're essentially going to abandon the asset either now or in the future. And it's very important to make those decisions on a granular basis for the asset and for the major equipment in the asset. And a lot of times when we work with our technology colleagues, our engineering colleagues, we're helping put some financial parameters for the client around how to rationally make those choices.
On this this question that you're alluding to, Timurhan, of the, I suppose, sort of the end-to-end life cycle of infrastructure, and ensuring that the data that's generated right up front when you're doing 5% design and the intention of the client is sort of established, is maintained through detailed design into construction and then into operations and maintenance, and the value of those data systems. Certainly in terms of sort of social or civil infrastructure, usually the funder is government, is taxpayer, whether it's upfront or spread over the life of the infrastructure. And delivery is through private entities like Arup and others and constructors. So Farrukh, I'd love your thoughts on the role of public-private partnerships in the delivery of infrastructure, and in particular around delivering more resilient and more sustainable infrastructure.
Sure. Before I come to this question, I wanted to mention there are two initiatives I've seen lately on digital twin. One is Destination Earth by European Commission, which is very interesting because it creates a replica of Earth to see and simulate and do scenario planning. And the second one I recently saw was by NVIDIA. It's called Earth 2. Which is very interesting as well. So for those of you who have not seen it, I think that is something very interesting. Now coming back to your question on government partnership, there needs a very clear policy work and framework that needs to be done by industry leaders, by governments, by technology leaders, basically providing incentives. I think that is needed. What we also need is data sharing. We need transparency and trust. We need data sharing between different entities. For example, as Schneider, if we are able to access data on energy consumption patterns from the utilities, from the government, that is huge data that we can utilize and actually inform and advise on what could be done, and vice versa as well. So there is a need for proper collaboration, data sharing, transparency and trust. Cybersecurity is a big topic. I think that's something that I would touch on. I think that is something where we need more framework around that. If we have to create a resilient infrastructure, all the data that a building or an industrial unit is generating, how secure is that, and how it is linked back into the public sector. So a lot of work needs to be done there.
Thanks, Farrukh. And to, of course, amplify that is that these standards are jurisdictional. And so, Ahmed, I would love your reflections on interoperability and common data standards globally. I mean, Esri's a global organisation that provides global data sets. What are you? Are there initiatives that are giving you hope that we're moving in the right direction in terms of this?
I mean, there's no other way. You cannot actually move forward without having the standards and the interoperability between the different data platforms, so you can actually benefit and make use of the data that is available out there. In fact, the United Nations, under their statistics office, the UN GGIM, has established a framework for an integrated geospatial data. It's called IGIF. And it's actually one of the because they believe and they know exactly that this is one of the foundational aspects for the country level, for the country to grow and to collaborate between the different agencies, whether it's private or public sector as well. It's very crucial. Data can be a nightmare if it's not properly integrated. And for that, there is data standards. There is the OGC, which is the Open Geospatial Consortium that sets the standards for the geospatial data. When we talk about engineering data, for example, we do partnership with Autodesk, so we can natively read the BIM data, the CAD data, all the other aspects as well, and try to make sure that this data is coming to the GIS system and the geospatial system in a seamless way. In a lot of the throughout my work with the AEC firms, one of the biggest challenges is how do we convert the schematics and the as-built CAD drawings that has no identity of location. Where would you place that building or the design that you had for that city, for example? So you can study it from all the other aspects, whether you're doing network planning, whether you're doing your electric grid planning. You cannot do that, and it can be a nightmare, to be honest with you. It's something that you cannot avoid. There is a lot of progress, and as I said, there is a common concept around that, and you probably see it on a country level, something that we call the SDI, or the Spatial Data Infrastructure, where the relevant parties in the country would be responsible for authoritative data that can be shared, can be reliable information that can be used across the different agencies as well. It can be also worked out with private institutions as well, in case they wanted to provide additional data on the top of that. So that's something that there's no escape from it. And the technology and the standards and the establishments there, I believe, have reached a certain mature level that is moving in the right direction, not as we would like everywhere in the world, but it's going in the right direction. Yeah.
Thanks, Ahmed. That's encouraging. And I'm going to come to the audience for questions in a minute. So please raise your hands if you've got one. One more question to John. John, I know you're working with the owners and operators of complex networks who have multiple complex data streams. How are we helping them think about how to optimize those infrastructure networks using data?
So that's a great question, and it's important because most of the buildings out there already exist, and they exist for a long period of time. And so it's important when we think about design and construction to think about how we would design given the new client realities, but a lot of it is how we optimize the existing footprint. And one of the interesting things is sustainability and decarbonization often has given companies a new tool, a new lens to look at business problems that they could have looked at in the past, but maybe didn't have the burning platform, no pun intended, to do so. And so now a lot of companies are going back and looking at energy efficiency in their buildings in a world that is likely to be hotter and wetter in many places. Those are often decisions that that pencil out very well, that save money. They're looking at how they provide heat in those buildings in a world where gas prices are likely to be very volatile. And so they're re-looking at things like geothermal, like ground source heat pumps. They're looking at generating their own power. And often, we haven't talked about data centers a lot, that a lot of data centers are starting to look at a world where they may not be able to get power from the grid. And so a clean electron may be the only electron that they're really able to get in a reliable way. And so they're looking at how do they generate that energy either through solar and wind with batteries, or through small modular reactors and nuclear, and looking at a lot of things that in the past they would not maybe have considered. And they're being forced to do that by the changing climate and by the drive to decarbonize. And a lot of that drives really powerful advantages. From a data perspective that you asked about, to be able to even make those decisions, it requires them to have a lot more data at the company level. And so in the past, where it may have been acceptable that an individual hospital or an individual store or office building, the data about the heating and cooling of that building stayed with the facilities manager in that building, it now needs to be on a single pane of glass in the corporate office so that they have all that data and they're able to manage those decisions across a large enterprise. So that's really changed the world, changed the way that that large organizations manage those kinds of decisions.
Fascinating. So I've found this fun. I hope you've found it interesting. If you could join me in thanking our esteemed panelists in the usual way.